We're going to discuss in this coordinate geometry is, I had to put circle geometry, but it should be coordinate geometry. Make a correction there. This circle geometry we did it last time, so this one is coordinates. Coordinates. Yeah. The coordinate geometry. And mainly for today we are going to calculate the distance between 2 points on a straight line. It has a symbol that shows that this is a 90 degrees angle. This one. This symbol showing that this line, line AB is perpendicular to line BC. Thank you so much. Let's just give him her a hand. Yeah, hand. Just put the value of x. Yes. Using Pythagoras theorem. Do we all know how Pythagoras theorem works? Yes. Thank you so much. So I would like you to try in your books to try working out the value of x. Can you do it? You got 2 minutes for that. If it's too much, you have 1 minute for that. Yeah, let's do it quick. Let me see where I put it up. No, not here, but here. The time which we were given has elapsed. Thank you so much. Who can come and do what exactly you have done in your books? Who can come? Janet, just fast. Here you have the piece of chalk. Are you done? Are you done? Yeah, before you go, can you stand here? Can you stand in front? Firstly, your friends. First, your friends. Do we all agree with what she has done? Yes. No? Yes. So if you don't agree, can you come and do yours here? Oh, it's just a correction of what she has done. Yes. Then you work it simply. You just want to make a correction. Okay. So, anyone of this different view? Thank you so much. So, do we all agree now with what she has done? Yes. So, thank you so much. Can we give her a hand? Yeah, so I think she has done a bigger part where others that just put where she missed. Thank you so much for correcting her. And this is very good. It shows that whenever we are working out on a problem, we are supposed to make sure that each and every step we are supposed to touch there. We are supposed not to omit any step according to the way we have done it. So the way we have done it as a class. Do we all agree? Yes. Thank you so much. So according to Robert, which has written here, it means that we have worked out the distance of AC by using the formula of by using Pythagoras theorem, we have worked out the distance of AC. Now, can you give me another ways of getting out the distance, of calculating a distance? Apart from Pythagoras theorem, any other methods of getting a distance? So by using trigonometry ratios. Thank you so much. That's the idea from Sylvia and Faith. Who else? Another pair. Janet, you are raising a hand. By using what? Also, we are also suggesting the same. Thank you so much. So we got so a lot of ways of getting the distance, but the main ones we have what you have mentioned. Then number 2, we have the one which we have used here, the Pythagoras theorem. Pythagoras theorem. Then we also have by using what we call and finally we also have what we call by using vectors. By using vectors, Pythagoras theorem, then the coordinates as well as the trig ratios. Are we together? Now, so today we are going to calculate distance by using coordinates according to the topic which says coordinate geometry. So coordinate geometry and the coordinate geometry, as the subtopic suggests that we are supposed to calculate distance, we are going to use the method number 3, which talks about the coordinates. Now, I'll give you a line. So I would like you, using the line, you have to calculate the distance. Can someone who is taller than me come and assist me? Can you speak, please? Yeah, you can sit down. Thank you so much. Now, can you take a look here? A line, line AB. You mean 4. This side? Yeah, it's a 4,2. 4,2. Everyone just don't know where to start, so you can think of where to start. Yeah, so a minute has elapsed. Who has finished? You have finished. Let me see. The coordinates are 0,2. Are we together? Yes. The coordinates, the way they stand, it means that this 0, it is a coordinate from x-axis. X-axis. And this 2, it is a coordinate from y-axis. Are we together? Yes. And likewise with B, 4,2 x
and y. Now, because they are standing on the same straight line from A to point B, therefore we are saying that at A, this x is x1, and this y, it is y1. Same with the B here, this one will be x2, and y, it will be y2. Now, we are going to use the values of either y or x axis. So let's take the values of x axis. So we are going to say x1 and x2 minus x1. Are we together?
Yes.
So it's like the car is moving from Masasa CDSS to ShopRite in town. Now, so Masasa, where it is starting, the car where it is starting its journey, that is the point, the original point, the point A. And in town, that is the point B. Now, where it is starting, it is like we are saying x1, and where it is ending, that is x2. So we are going to say subtracting the distance of where the car stops and where the car has begun its journey. Are we together?
Yes.
So let's take as x2 as the car total in town, and the x1 as Masasa right here where we are. So we are going to say x2 minus x1. What is the value of x2?
4.
So the value of x2 is 4. Minus, what is the value of x1? 0. So we are going to do 4 minus 0. And the answer is what?
4.
The answer is 4. Are we together?
Yes.
So the distance of line AB is equal to 4. Are we together?
Yes.
Now, so that is what we have done here. So what if this is a straight line? Now, what if I give you a slanting line? What are we going to do? My friend Eto, the tall person just like I am, can you come and assist me again? So let's see. Let's work on it. Let's work on it. Flora, let's see what you can you start with. It's working now. This is 1 plus 4. Where are you getting this 1? Who can just summarize what you have done? Who can say to share with the class? Felisana, have you said anything in this class? No, hey. So it's your time. Let me give you the chance to explain. Explain what you have done. What have you done? What have you done? You can stand up and tell the class. Can you say in English? Or maybe just come if you can't express yourself. Right. Okay, so this is what she has done. Anyone with a contrary idea? She has done this. Do we all agree? No. Who has a contrary idea? Who says no? Yes? Vidumbiko. y2 minus y1. Okay. Do you understand what you are collecting? Don't go. Do you understand what you are collecting here? The collection you have made. Do you understand? Where is y2? Can you show us the y2 there? Oh, so 6 is our y2. So, why do you think at first you were supposed to put y1 here? What made you to put y1 at first?
Because I was starting to write it in inspired.
Okay, thank you so much. So, because she thought that B, that is our starting point. Are we together? So B is our starting point, and the A is our point. So that's why she made the mistake in that way. But even if you wrote in that way, were you correct the way you think? Were you correct in getting the answer? Yes, thank you so much. Okay, so I hope we are all in the same idea. Are we together? Yes. Now, this is how we get the value. This is how we get the value of what we have done. But for us to get the value of A, we can simply do what we can do. For us to get the distance, can you come, my friend? So there is a way. There is a way which we use for us to get a distance for this slanting line. What we do as we can see here. Yeah, so just like the Pythagoras theorem which we used here at first, what did we do here? We said this ACAB squared plus BC squared. This is what we did at first. Do we all agree? Similarly here, with this slanting line, we are supposed to use both the sides, both the values. As our friend Feliciana did here, she only took one side. She only used y minus y1. That's what she used. Now, because here we're having a slanting line and with the coordinates from both axes, we can use the method just like we have used here. So it is x squared, x2 minus x1 in bracket squared plus y2 minus y1 in bracket squared, just like what you did here. Felician, do you see it? Just like what you did here, then you are going to put in a blanket and you square this one. You add the same thing we have done here, but you should change the variables here and put x. So just like we have used here. And we put this shape, a root sign, covering the whole of these variables. And we get to the answer just like we have done. And we get the answer as 4.12. But the question now is, how come we have used this? How come we have used that one? And why are we supposed to do this one? So to answer that question, that's where we are saying that for us to calculate distance using coordinates, we use a formula for distance. And the formula for calculating distance is this one. This is the formula for calculating distance. How do we get this formula now? That's where it was for deriving a formula. So deriving a formula, you are going to derive a formula in this way. So I think let me change another tall person this time. Who is tall? Faith. Yes, you are taller than me. Can you come and assist? Line A up to B, then we are having the sides here. X, y1. Do you see that one? So x, y1, because of, at first we had to put the values here, but this time now we have used the variables. Instead of putting a real number here, we have used a variable of x and a variable of y. And b likewise. Now we are going to draw a line to make sure that we complete a triangle just like we did at first here. Do you see this one? And where these two lines they are going to meet here. When we start from this side going in this way, that means we are going to stop at where x is x2 and where y is y1. Do you see that one? Yes. Now we are going to make a formula now using Pythagoras theorem. So using Pythagoras theorem, for us to get the distance AB, we are going to use the formula just like what we have done here. AB squared equals AC squared plus BC squared. Do you see that one? Yes. Then we are going to substitute AC, which is x2 minus x1. We are subtracting x2 minus x1 to get the distance of this part. And we put it here. And we are going to square it, just like the square which is appearing here. Likewise, this side now, we are going to say y2 minus y1 in a bracket. We are substituting it with the BC. Then, for us to get rid of, to get the value of AB, we are going to get rid of this square by putting a square root here, a root sign, just like our friend did, Bikumbiko Halawa used here. Do you get it? So the same idea has been also applied here, and we found ourselves that we have used this formula, we have used this root sign, this other side. Is there anyone being left behind here? From here up to here? Martha Banda, are you being left behind? Are you being left behind? No? Okay, fine. Now, then the formula for distance is equal to this one. Therefore, for us to get the distance, we are going to just substitute the values which will be given in terms of the coordinates being substituted here. Anyone having a question here? Now, so I will ask you, why have you used these two lines covering AB? Any idea? Okay, these two lines here, they stand for distance. They mean distance. So it means distance AB. Are we together? Yeah. Up to this time now, let's do the exercise now. Exercise. We don't have a question. That means it's loud and clear. And let's do the exercise. I have said we are just going to substitute the values here. Where there's x2, we put x2.
Yeah, so I think the first two people, they have managed. Yeah. Yes? How much? This one. Yeah, so the first two people, they have managed. I'll keep it. I think you submit it when you are finished with this other one during the second grade. Are we together? So the answer for this one, after using the formula, we are going to substitute it in here. Our x2. What is our x2? 5. So our x2 is 5. That means we are going to put 5 here. What is our x1? Negative 3. So here it will look like 5 minus how much here? 3. Then you are going to put in the blanket squared plus what is our y2? 7 minus what is our y1? 1. So you are going to substitute this way and you square this one and you get the answer. What's the final answer? The final answer is 10. I hope we are all in the same vessel. Yeah, so today's lesson, it ends there. That is the end of our today's lesson. And I may ask you, why are we learning this topic? This topic is important in navigation. It is important in making calculation, for example, for those people who do construction work, who do the buildings, who construct the roads. It helps them to what? To make the calculation that if from here to that side, how much is the distance? And to the part of you as a student, it helps you to think critically. Are we together? Yes. Yeah, so what have you learned in this topic? What have you learned in this topic? Yes.
Finding distance using coordinates.
Finding distance using coordinates. Yeah, that's according to Robert Super. Okay, who else? What have you learned? Yes, Janet. Formula for deriving formula for distance. Are we together? Thank you so much. Until we meet in the next topic, and in the next topic we'll be doing the finding the distance or using the gradient. Are we together? Yes. Thank you so much.